Good afternoon, everyone. Welcome to our first CSEC session for this term. We will start momentarily, just awaiting other students. So while you're here, please go ahead and type your name and the name of your school in the chat. All right, welcome everybody. Please type your name and the name of your school in the chat. We will begin in 3 minutes. All right, again, just inviting you to type your name and the name of your school in the chat, please. Okay, welcome again to another of our webinars put on by the Region 5 Mathematics team. Today, we're going to be focusing on problem-solving strategies, unlocking mathematics through conceptual understanding. And the focus of today's session is concepts relating to measurement. Welcome, everybody. Again, please type your name and the name of your school in the chat. I'm Janice Simpson-Hales. As usual, before we get into the session, we're going to have just a little icebreaker to see what you're thinking, giving you the opportunity to test your microphones to see that they're working so that you can respond during the session. Somebody needs to be muted. All right, so here we go. So place the appropriate digits in the box to make the following sum possible. All right, so here we are. So you are to replace those boxes with digits to make the answer correct. All right, feel free to type your responses in the chat. What digits should be here so that the sum is correct. All right, so somebody is saying 1, 9, and 0. All right, thank you so much. I'll also invite you to change your name, the name of your device, so that we can identify you clearly. All right, somebody says first row down. All right, so it's the same person. Somebody is saying 2, 0, and 10. All right, be careful with that one. All right, so we're not going to spend a lot of time here, but let's see. Let's take one more response in the chat, and then we will reveal the answer. We'll have that big reveal. Anybody else giving it a try? One more. All right, no? Let's go ahead. So let's see if the responses so far are correct. All right, so in the ones place there, the missing digit is 0. All right, because when we add 2 to 8, we'll have a sum of 10 and representing 0 ones and one group of 10. And when we take that one group of 10 to our tens column, we now have one group of 10, 7 groups of 10, and so we need 9 here in order for our digit of 7 to be correct in our sum column for the groups of 10s. And when we complete that sum, of course, we're going to have one group of 100 to take over there. And in order for our hundreds to be 5, we have to have 1 in that position. All right, thank you so much. I think somebody got this correct, the first person who responded. Thank you so much. All right, so we're moving into today's session and our focus, we have 3 objectives that we want to meet, 3 areas of focus. We're going to be exploring some common problem-solving strategies. We're also going to attempt to distinguish between area and volume. And we are also going to be looking at a CSEC task relating to area and volume. All right, so if you're interested in these objectives, that you'll be able to better understand some of these concepts, go ahead and type yes in the chat for me. Show me that you're ready. Go ahead and type yes in the chat. All right, great. All right, Christina, we're ready. All right. So our problem-solving stages. So we're looking at problem-solving strategies. And what this really means is that when we look at a task or a question, we have to decide what approach are we going to take to solve this problem. The answer will not always be readily available to us. So we have to stop and think about the problem and how we're going to approach the problem in order to arrive at a solution. So there are several stages of problem solving. First, we need to understand the problem. Then we need to do a little bit of brainstorming. So, have I seen this problem before? Does it resemble something else that I've seen? How did I solve that other problem? What am I going to do? What am I going to take from that to help me to solve this problem? So you have to brainstorm. And then once you have brainstormed and you thought it through, then you begin to look at, all right, what approach am I going to take to solve this problem? What strategies will I employ in order to arrive at my solution? And so of all these 4 stages that exist in problem solving, our focus today is going to be on stage we're going to be looking at strategies that we can utilize to solve problems. All right, so here's our first task. We're looking at tiling a room. Right, so Mr. Jones has a total of 25 tiles to tile a room. He's not sure if it is enough. The tiles are each 40 centimeters by 50 centimeters. That means the longest side of the tile is 50 centimeters.
Yeah, done. Do anything you want.
Shortest.
I want zinc on me. Exactly. We can.
The shortest side of the tile is 40 centimeters. All right. So, and we're going to look now at the dimensions of the room. So the room is 3 meters long and 2 meters wide. Our question is, does he have enough tiles? Why or why not? Feel free to type your answers in the chat. But again, we want to look back at our stages. First, we must understand the problem. Understand what is happening. Then we're going to decide on, we're going to do some brainstorming. What can I do? Where have I seen a problem like this before? And then we get into our strategies that we're going to select. And again, our focus here is on the strategy. So even though you're going to be thinking about how you could solve the problem, I also want you to focus on what strategies could you employ to solve this problem. And you might not be aware just yet of some of the strategies that exist, but as we go through the presentation, you'll become more familiar with some of the strategies that exist that we can utilize to solve problems in mathematics. All right, so what are you thinking? Let me see some responses in the chat. There are not enough tiles. All right. So somebody jumped right in and said there are not enough tiles. Would you care to share why is it that you decide that after examining the problem and brainstorming about it and came up with your strategies, you decide there are not enough tiles? How did you do that? Why have you decided that there are not enough tiles? Can you give me some more information about your decision-making process? The units have to be the same.
That the units, okay. I was going to read that for you.
Thank you, Doctor. All right. Also, let me just pause to welcome Dr. Isilda White. She's also a member of the Region 5 Mathematics team, and she'll be working with me this afternoon throughout this session. Welcome, Dr. White.
Thank you.
All right. So it says the units have to be the same. You're sure about that? All right, there's a little thing called conversion of units that we'll delve into just a little bit. But so that's the only reason that you have decided that the tiles are not enough. All right. Anybody else? The area of the room is 60,000 square centimeters and the area of one tile is 2,000 square centimeters. I've seen some calculations taking place in the chat, Doc.
Yes,
So
Christina is saying, since Mr. Jones has 25 tiles, he does not have enough tiles. He would need 30 more tiles to tile the room.
all right. All right.
And
So I think
HB Global is saying the area of the room is 60,000 square centimeters.
Yeah, dirty attitude too much in when I hear me.
all right. All right. Remember, we're online, so we're gonna try to be respectful to the online space. All right. Thank you, Doc. So we're seeing some thinking taking place there. All right. So some persons are saying you need 30 more. Some are saying you need 30 in all. All right. No problem there. But we want to spend a little time now talking about what process did you go through to arrive at this answer. So right away, you delved into your calculations because you're mathematicians, right? But we want to spend some time on the thought process that goes into it. So, for example, one of the things that we could do when we look at a question like this is to start off by saying, would a diagram be helpful if I were to just kind of draw a little sketch or something of what the question is saying? Would that help me to be better able to come up with a solution? You know? So I could draw a picture of it to see what is, so put it into some kind of perspective. You know, some persons can just look at the question and delve into an approach to find an answer and so on. Some persons may have to do a little sketch of it for it to have some kind of visual representation to see what it looks like, and therefore what do I need to do. Anything else? What else could we do? I'm giving you a hint of one of the strategies, which is to draw a picture. Is there any other strategy you could think of that could help you in arriving at a solution to this problem? Any other strategy mentioned in the chat, Doc?
Not yet, Mrs. Sales.
Not yet. All right. I'm sure they're thinking. Right. So do you agree? Yes. Somebody's saying, yes, of course you could draw a diagram that would be helpful. Sure. In addition to that, we could sometimes, which is I think what our colleagues did just now, they wrote a number sentence, they wrote a little equation kind of to represent what they're seeing and to say, all right, then I can use this to represent it. I know how many tiles I have. I also know the dimensions of the room. So I can set this up in terms of a little number sentence, a little equation to try to see how I would figure out how I could solve the problem. So that's another strategy, actually. Also, we could make a model. Some persons have some time and they could actually cut out a little cartridge paper and cut out the little tiles and try to fit them on and make sure they have the correct dimensions and so on if you have space, because I mean, this is kind of requires a certain amount of space to do that, but you could create that model as well. Equations is also a model, while it also falls under the idea of number sentences. So we're thinking about, because sometimes we arrive at our answer, we just jump right into the solution, and we don't spend any time thinking about what was the process I went through to arrive here. So these are some of the strategies you could use to help. We could also make a list. And in this case, what does the list represent? We're writing down the key bits of information that we have in the question. What are some of the key bits of information in the question that would have helped us to arrive at our solution? Go ahead and type in the chat. What are some of the key things you can list from the question that you're definitely going to be utilizing to arrive at your solution? All right, let's see. What are some of the key things? Type in the chat. Look at the question, highlight some of the key things that are useful to help you to arrive at the solution. Let's see what they're coming up with, Dr. White.
Okay, I know they're thinking, but nothing is there as yet.
All right. What are the key things from this question that you can say, yes, this information is useful for me to be able to answer the question? All right, somebody's saying the number of tiles. There's a big paragraph there, Dr. White. Share it
Yes.
with me.
Okay, say I calculated the area of the room by multiplying the length and width in centimeters. Then I found the area that one tile can cover by multiplying the dimensions of a tile. Sorry, then I divided the total area of the room by the area of one tile to determine the number of tiles needed. Mr. Jones needed 25 tiles, but Mr. Jones has 25 tiles, but needs 30 tiles to cover the room. He doesn't have enough tiles to complete the tiling.
All right, thank you so much. So in that list, you identified the number of tiles that he has. You also identified the dimensions of each tile. You also identified the dimensions of the room. Those were critical bits of information that you needed in order to do your calculations. Thank you so much. All right.
And
Let's
Lee
see.
Marie says 40 centimeters by 50 centimeters.
All right, so that's the dimensions of the tile. There's also another strategy, which is identifying a pattern. It might not be so applicable to this question, but it's a strategy nonetheless. So when you approach a particular question, you could look to see, is there a pattern developing here? And what is connecting these elements of the question through that pattern? If I continue with that pattern, I could arrive at my solution. So that's also another strategy that can be utilized. And another one that you might not even think of as a strategy, because you do it all the time, but it's guess and check. Sometimes you have to make a guess and then check to see how good your guess is. And as you continue to refine your guess, you will ultimately arrive at your solution. So those are at least 6 strategies that we have looked at so far, 4 in relation to this specific question and 2 additional strategies outside of that. And there are also other strategies. We're going to look at some other ones briefly. So we have make a table. That's a strategy that you can utilize when you want to condense the information that you have. So you have some information, it's a big paragraph and so on. It gives you some bits of information, bits and pieces of data. You want to put that in a table so you can better organize the information, so you can begin to brainstorm and then move into your solution. All right, make a list was also there. We could act it out. Sometimes doing these, putting yourself in the role-playing positions and so on, you along with your friend can role-play the particular question and so on, taking out the relevant elements and somebody asking the question and you're trying to brainstorm. That's also another strategy. All right. Another strategy as well is to work backwards. So you start with your answer per se, and then you go back based on your information in order to arrive at where the question would have started. So those are other strategies. And sometimes we can simplify the problem, So instead of working with large numbers, if we see where we can divide through by a factor to make it a smaller equation for us to solve, that's also another strategy. So share with me in the chat, have you thought of any of these strategies before in working out your questions? Or have you just tried to figure out, just jump to writing down answers and so on? Have you ever stopped to think about the process that you go through to solve your problems? Dr. White, I'll allow somebody to open mic and just share on that thought.
Okay, Mrs. Sales.
You can show your hand if you'd like to respond to that question, and we will take your point. All right. Have you ever thought about the process that you go through to solve your problems before you actually start writing down numbers? Anybody would like to share on that point?
All right. Christina is asking you to repeat.
All right. So I'm saying, when you are given a task to answer, you have a question that you'd like to answer, a mathematical problem. Have you ever given much thought to the idea of how am I going to approach the problem before you begin to write down your numbers and trying to do calculations? That's what I'm asking. Who's speaking? All right, there was a hand, Dr. White. I think Lemia, I'm not sure.
Or is it Lee Marie?
Lee Marie, right. So sorry about that. Go ahead. Can we give her the opportunity to speak?
Sure.
Go ahead, Lee
Miss,
Marie. Yes?
well, it all depends on which question I'm answering to. If it's a question that goes with a large amount of numbers, I will take some time to pull apart the question and then answer it. As Miss Robinson always said to me, that's my maths teacher, she always said that use a better clue or find some way first before you just target the answer like I normally did. I just answer the question, but she taught me that instead of just going ahead and answer without understanding what I'm doing, first to break the question apart so that I can understand it properly. So when I'm in class and to give my classmates a better explanation, I would know how to do it properly without being confused.
All right. Thank you so much for sharing. I'm sure others would have benefited as well.
And HD Global is saying, I tried to map out the problem using drawing.
All right. So you like to draw a picture. That's nice. Christina, can we unmute Christina? Give her the opportunity to respond now.
I
Christina
am not able
Williams.
to unmute her.
All right. Let me see if I'm able to. All right, Christina, you're unmuted. Would you like to share now? Your hand was up. Still is.
Sure.
Go ahead.
I consider the information provided in the question, whatever
Right.
question it is,
Mhm.
and then I plan out the steps needed to solve the problem by
All right.
breaking down the problem into smaller parts and
Okay.
applying relevant formulas or concepts. I also work through the calculations to arrive at the final answer. And to me, it's like putting together puzzle pieces to find the solution.
All right, great. Thank you so much for that. So one of the main things we want you to leave this part of the presentation with is the idea that you must think through the question before you attempt to solve. And in order to think through, that's the area that we talk about. You must understand what you are being asked to do. So that's very critical. Not because you see a question, you just go right into it. Spend some time to understand what you're being asked to do, and then you can do your brainstorming, decide on your strategy to solve, and then go ahead and find the solution. Thank you so much for responding. All right, so we're going to be doing a little bit of that now, because we're going to start with this question. So look at the question very carefully. A rectangular plot of land has a perimeter of 180 meters. If its length is twice as long as its width, what is the width of the plot of land? All right. So again, we have 3 columns here. And you notice we have this very interesting column in the middle. It's the strategy. And that's what I want you to spend a minute or two thinking about now. What strategy would you employ in order to help you to arrive at your solution? All right. So I'm giving you a minute or two to think about that. You can go ahead and type in the chat. We looked at some strategies. We could type up some of these strategies in the chat to make it easier for you to remember. But we have, for example, to draw a picture. We have to guess and check. We have to find a pattern. That's one strategy. We also had other strategies that we looked at. Working backwards is a strategy. Drawing a picture already. Making a model, a number sentence. So that's like writing an equation or doing some cutouts and so on. Those are some of the strategies. Which of those strategies do you think would be helpful in arriving at a solution to this problem? Is there something in the chat, Dr. White?
Yes, HD Global says using equations.
All right, so equations would be nice. So that's equivalent to writing a number sentence or using a model. Thank you so much. Anything else? The moment you say rectangular plot, something should come to your mind, man. Most persons, they see a shape. The first thing they begin to do is to do what? Let's see what
Alias says, I will draw a picture.
So that's also a very good strategy. So we could start by
Lee Marie says drawing a picture or a diagram.
All right, very good. So we could start by drawing a picture so that we have a good idea of what the question is asking us to do. And we could also make a model, which is, of course, equation can be a form of modeling as well. So we could do that. So what would our picture look like? So we say, all right, we're going to draw a picture. We know it's a rectangular plot. So clearly, I'm going to attempt to draw a rectangle. And in drawing a rectangle, what are the properties that my picture should have? I'm just doing a sketch now, but in recognizing, for someone to recognize this picture as a rectangle, what are some of the things that has to be there? Who would like to share in the chat?
All right, Christina says use information provided. And also, Mrs. Sales, just to let you know that the problem solving strategies, they are in the chat.
All right, thank you so much, Dr. White. All right, so the problem solving strategies are there in the chat. So look at them to get some idea as to the ones that are available and which ones you think would best suit this question. All right, great. Thank you so much. So we're looking at it's a rectangle. So what is it? What are the bits of information from this now that we need in order to label the rectangle that we have? Because we draw the rectangle now we draw our picture, but we have some information that we need to take. So we're going to make a list from the question. What are some of the things from the question that is essential to help us to draw the diagram?
All right, I have some responses here. Christina
Sure.
says use information provided.
Yes.
Lee Marie says width and length. And
Right.
H Global says dimensions. And he also said, he has the word perimeter as well.
All right. No, so those are key things that we're making from the list. But what is it about the words in the question that is going to help us to label our rectangle? What are the key points from the question that will help us to label this rectangle that we have here? But we can't just throw in values anywhere. Anybody would like to share? What is it from the question that's going to help me to label my rectangle?
All right, not seeing anything here yet.
All right, I'll reread the question. A rectangular plot of land has a perimeter of 180 meters. If the length is twice as long as its width, what is the width of the plot of land? So what information will I put on to my rectangle?
All right, Alia says the length should be longer than the width, and HD Global says the length is twice as long as its width.
Good. So which one am I going to label first? Will I label my length first or my width? Of course, we know they're both distances, but we usually associate the shorter length as the width and the longer length as length. That's how we normally label. So go ahead, no problem. So we start by identifying our width. So if our width is W, I'm using a letter to label my width. So if our width is W, what can I say about the length? What can I say about the length if the width is W? Because I'm finding the width. I'm saying let my width be W. What labeling would I put for the length of my rectangle? Anybody have that in the chat now?
Okay, I see a number of comments. Well, somebody saying length, width, HD saying give it a variable name.
Right.
Lima is saying width, and HD Global is saying 2W.
Ah,
The saying length.
right. That's what I want to hear, Doc. But in addition to that, because we're dealing with a rectangle, I'm only going to be labeling one side. But I am using this symbol to indicate that both lengths measure the same. So if this is my width, then parallel to my width will be the other length of the rectangle that measures the same. So of course, my length, as HD said, is going to be 2W, and I identify what length I'm referring to as 2W there. And then can somebody tell me where else on my diagram would also measure 2W? Anybody else can tell me? All right, so parallel to my 2W there is my 2W at the bottom there. So now that I've drawn my picture, and somebody had also said somebody had also said that we could now use an equation. What would my equation look like? Can somebody tell me what the equation would look like? Now that I have my diagram and I know that my equation can be a model. So now that I have my diagram, what would my equation look like? All right. Because remember, we're working with the concept of perimeter. Now I know I have a labeling for my width. I also have a labeling for my length. I know to make a model in terms of an equation, what would that look like? What do you have, Doc?
Well, I'm not seeing any. Oh, here is Christina. Christina
Yes.
has 180 equals 2 bracket 3W.
Okay. 2 open bracket 3W.
Yes.
Okay. Would Christina like to explain that approach to us? How did you get that, Christina? Why do you have 2 open bracket 3W? Christina, would you like to share? Because I think that's a nice way to represent it, but I'm not sure if everyone is following how you arrived at that. So could you open mic and share with us, Christina?
All right, while she's getting ready to speak, Rachel says 180 divided by 4, and Xavier Hewitt says divide the perimeter by 3 to get the width.
Divide the perimeter by 3. All right. Could Xavier explain that a little bit more? All right, they're not talking to me, Doc. Are they
I
typing?
don't know, they're not speaking to us at all.
All right, no problem. So what we're gonna do, we're gonna take a very simple approach because I saw some advanced algebraic approaches, not too bad. But we're gonna take a simple approach just to make sure that each person that we're on the same wavelength with this question. All right, so we're gonna set up an equation. So before we set up our equation, the first thing we need to do is to identify the variables that we're utilizing. So we're gonna say let W represents the width, and therefore, remember now the relationship between our length and our width. So our length is twice the width. So of course, 2W will be used to represent our length. And so because we are calculating our perimeter, and we know that our perimeter is a measure of the boundary of the shape, and we know the length of the different sides in terms of W. So we could say 2W plus 2W, so we know we have 2 of those, plus W should give us a measure of 180. All right, can somebody solve that equation for me? If I have 2W plus 2W plus W is equal to 180, what is the value of W? What's the value of W?
All right, Xavier says 30, Christina says 30.
All right, so let's see. There you go. Congratulations. So we moved from task to devising which strategies we could utilize to solve, and then moved into arriving at our solution. That's a nice flow. All right, we have another one coming up. Let's look at this one. Sarah has some pens. She bought an additional 34 pens. She then threw away 29 of them because they were spoiled. In the end, she had 64 pens. Here's your question. How many pens did Sarah have at first? All right, so I'm giving you a few minutes to think it through. Remember the process that we're going through. We're gonna look at the task, think about the strategies, and then move into our solution. All right, we know we're working in relation to time, so we're bearing that in mind. All right, so again, Sarah has some pens. She bought an additional 34 pens. She then threw away 29 of them because they were spoiled. In the end, she has 64 pens. How many pens did Sarah have at first? All right, remember what we're going to start with is thinking about what strategy or strategies we could utilize to answer this question. And then we move into our solution. So any suggestion relating to strategies, Dr. White? Again, you can look back at the picture.
All right, not yet, Mrs. Hales, but I know they are thinking.
Oh, certainly. So you could look back at the picture that was posted in the chat to see a list of the strategies and to identify which of those strategies, whether one or two or three, could be applicable to answering this question. All right. There's a hand up. Is it that Christina would like to offer a response? All right. Anybody with the answer to this question?
All right, there's nothing in the chat as yet, Mrs. Hales.
Nothing in the chat as yet. Can you figure out how many pens Sarah had at first? Something popped up in the chat, Doc?
Okay, Christina has 99. Lee Marie has 25.
All right. Okay. All right, so we're gonna see how accurate those responses are. So we're gonna look at some strategies. So one of the sorry, go ahead, Doc.
Davis has 59.
Okay.
And O'Connor says 93. But he was saying he wasn't here at first.
Okay.
Georgiana says 59. And Tia says 59. Dejanay 59 and Christina 59.
All right, thank you so much for those responses. So let's see who is correct. All right, so we're gonna start. A strategy that is useful here, which I think you probably would have employed that strategy as well, is to work backwards because we know where she ended. And so we have to go from where she ended to figure out where she would have started. So working backwards is a good technique here. We could also draw a picture, and this picture could be in the form of a diagram or so on. All right, so that helps us to condense the information and present it in a way that it's easy for us to understand. So here's a diagram that could represent it. So we knew that she started with 64. All right, before she threw away, because we're going back, we knew that she would have had the 29. So we must add back the 29 to where she ended. All right. And then before she threw them out, she had bought 34. So when she started, remember, she started and bought 34. So if we're going in reverse, we'd have to find out what was it before she got those 34. All right. And so that is what our diagram would look like, working backwards. All right. Anybody like this diagram? Would this have been useful for you to arrive at a solution? And I'm seeing some person saying, yes, I got 59. And somebody else would have had another value. All right. So how did you arrive at your 59? There were some persons who got 59. What approach did you take? Could we take one of those responses, Doc?
I think Christina should explain because she has it all worked out in the chat.
All right. Go ahead, Christina. Could you open your microphone and share with us? All right. Go ahead, Christina. I see you have it all nicely written out in the chat, yes? But go ahead. Talk to us, because in this presentation, we're mainly concerned not just with the answer, but the process that you went through to arrive at your answer. All right, go ahead.
Okay, so Sarah originally had 59 pens, which means that before she added the extra 34 worth of pens, she threw away 29 of them. So she would have a total of 59 in the end.
All right. Thank you so much. So this is a good strategy to employ with a question of this nature. Really working backwards from where you started. So even though I think you probably said it a little different just now, but she would have thrown away the 29 after she bought the additional pens. So we'll make that adjustment there. All right. Well, thank you so much for sharing, Christina. So here's a diagram that can represent it. And for those persons who like to represent it in terms of making your statements and so on, we could actually write down the solution in this way. So of course, you would have ended with 64, and we have to add what it is she threw out because we're trying to get back to where she was additionally. And then we have to subtract the amount that was added to the original amount, because it's the original amount that we're trying to find. And that takes us to a start of 59. And if you work going on now from start to finish, you should still end up getting your 64. All right. Are you enjoying the session so far? A lot of insights being shared. All right. Here's another one. When the perimeter of a quadrilateral is 16 units, its area is 16 square units. When its perimeter is 8 units, its area is 4 square units. When its perimeter is 4 units, its area is 1 square unit. Can you name that quadrilateral? Let's see what they will come up with, Doc. And again, remember, we're focusing, while we need the answer, our focus is on your strategy. What strategy would you employ to help you to arrive at an answer to this question? Is there anything in the chat, Dr.?
Not as yet.
Not as yet. All right, we're giving the students an opportunity to think it through. Again, the first thing you have to do is to understand the problem. All right? Once you understand the problem, then you begin to brainstorm. Think about, what can I do? Where have I seen something similar? And you go through that process. And then from there, you decide which strategy would be most useful to help me to solve this problem. Anything else?
Davisha says draw.
All right, so Davisha wants to draw. All right, no problem.
Lee Maria says the numbers are going in a certain arrangement.
All right, so that means it sounds like she's picking up some kind of
pattern.
Ah, all right. Anybody else? So there's some strategy going on. Somebody saying they would draw. Somebody saying they can identify a pattern. All right.
Okay. Yes, another one is here saying, Rachel says draw and label it to have a better understanding.
All right, great. So that's what we're gonna do. So one of the key things, one of the best strategies for this particular question is to make a table, because we realize that there's some information that is occurring. So we have at least 3 rounds of information. So representing that in a table would be useful. And then we could also work backwards a little, because if we notice about the 1 square unit, then we notice we have 4 square units, then we notice we have 16 square units. So that's kind of a clue there as to what is happening. All right. And we could also draw a picture. In some instances, we can do some guess and check. Let's check it out for one shape, one quadrilateral for the first round of information. Try it again to see if it works for the second, and so on. So all of these strategies are useful to arrive at a solution. So here we are. We're going to set up our table. And if we notice the perimeter is 16 and the area is 16, what could we say about one of the sides of this particular quadrilateral? Anybody? The area is 16, perimeter is 16. We have 4 sides. Can you tell me what you think? Guess. Start out with a guess and see if you're correct. What do you think could be the length of one of the sides of this particular quadrilateral? Anything in the chat, Doc?
Yes. Lee Marie says one side is 4. Xavier says 4.
All right. So we have 4 there, 4. All right. All right, no problem. What about this one? Because whatever translates, because it's the same pattern we're following, whatever happens in the first instance has to happen again in the second instance. So we're noticing that we could have 4s there, and it would give us an area of 16 when we multiply those sides. And we could also have a perimeter of 16. Great. What about if my perimeter is 8 and my area is 4? What could be the possible sides of my quadrilateral? What could be the length of the sides of my quadrilateral?
Lee Marie says 2.
Ah, something happening here. So it seems as though there's some kind of pattern. All the sides seem to be having the same dimensions. What about if my perimeter is 4 and my area is 1 square unit?
All
What can I
right,
say about the sides?
Lashante says 2, Lee Marie says 1, and a number of persons saying 1. Xavier, Aquila,
All right.
a
So
number of
then,
ones in the chat.
thank you so much. So then, can you answer the question? Name the quadrilateral. Which quadrilateral is this? Nothing in the chat, Doc?
Not yet. All right, the answer is a square. That's from Christina. Square coming all the way, Aquila and Alia.
All right. So it says a shape that has its length equal to its width. And of course, that is in fact a square. Very good. All right, so we're going to talk some common units of length now. All right, so going back to our question just now, we're looking at the first one in particular. And let us say we know that our sides are each 4 units. So right now we're using the term units because we have not specified a unit. All right, but what if we were to specify a unit? So of course, in this particular case, we know that we have a length of 4 units and a width of 4 units, and we know that our area is 16 square units. All right, but what if we had our length each being 4 centimeters now that we assign a unit? What would be the area covered by this square? What would be the area covered by this square? Anything in the chat, Doc?
Not as yet.
We know that the sides are each 4. What's the area? We have it in terms of centimeters now. All right, so we would have 16 square centimeters. Let's try another one. I'm just warming you up. Don't worry. All right, what if, are we doing a little bit of conversion here? What if the dimensions of my square were each 40 millimeters? What would be the area of my square? Anybody?
Not yet.
All right.
Okay, Christina says 160 milliliter.
Say again.
Christina says 160 milliliter.
Milliliters?
Yes, and Lashante, 160 centimeters. Xavier, 160 millimeters.
All right,
Well,
we're working in terms of millimeters. But
a number
remember,
of 160 coming up.
all right. And so our units is very important here because now we're no longer talking about centimeters. We're now talking about millimeters. So our area is 1,600 square millimeters. And one more for you before we move on. What if my dimensions are each 0.4 meters? 0.4 meters. What is the area of my square? 0.4 meters. What's the area of my square? Anything in the chat?
Not as yet, Mrs. Sims.
I'm sure they're working.
Okay, here comes Lashante, 0.16.
You sure?
Christina says 160 meter.
You sure? Check it again.
Rachel says 0.16 meter. And so says Xavier.
You sure? Remember now, in this case, we know the dimensions would be 0.04 and 0.04 and 0.04 and 0.04.
All right, Dejanay is saying 0.0016 meter.
Square meters. All right, thank you so much. So of course we can translate between our units of length. And these are not all of them, but just some of the common ones that we may encounter from day to day. All right, so we're getting now We're going to talk about area. So how can what can I do to find the amount of space this rectangle occupies? This is a broad question, but let's hear what you have to say about it. What can I do to find out the amount of space that this particular green rectangle on your screen occupies? And we're taking this down into a concept that perhaps you may not have thought of it this particular way. So I'm hoping you're gonna find it exciting. So I'm gonna funnel you in a direction a little bit, but all right, Omari, please do not write on the screen. All right. So what can I do? What can I do to find out the amount of space? And of course, we're going into strategies, so on, not necessarily in terms of calculations. All right. So one of the things that we could do actually is perhaps we could compare the space to be covered on the rectangle with another shape for which we know the area. All right. So come with me. What if I decided to cover this rectangle with triangles? All right, so let's see. So I'm going to record this area in terms of triangles. Now if I know the area of one triangle, can I find the area of the rectangle in terms of triangles? So let's say one triangle represents 2 square units. Do you think the triangles give a good coverage of this particular rectangle? Share your thoughts in the chat. Do you think the triangle gives a, calculate the area, fine, measure it, all right. But do you think these triangles give a good coverage of the rectangle?
All right, Lashante says no.
No, why not?
So
Is there
says
any answer?
Dijane. Maybe one
Any
of them
reason?
could explain.
Any reason why? Any reason? Anybody want to share a reason? Anything yet in the chat now?
They're all saying no. HMD Global is saying no, it doesn't account for the area at the bottom.
All right,
And
so
there's a gap there.
all right, so there's still some space left uncovered. All right, no problem. What if I decided to use circles? Is this any better? Does this give a good coverage? So I could say the area is X amount of circles.
They're saying the edge is left out and there are gaps, and I'm seeing no, and there are still gaps, and they're still saying no.
All right, so that don't work then. All right. Suppose I said, all right, let me try some parallelograms. How about this one? Does that give a good coverage?
All right, they're saying no.
No? All right, I suppose they're giving the same reasons. What about this one?
Yeah.
What about that one? Is this any better? If you were to compare them,
Lashante says yes.
This gives a better coverage?
Yeah, they are saying yes. A number of yeses in the chat.
All right. So which shape would you say gave the best coverage? The chat is lighting up.
Square. Yes, Xavier. Yeah, everybody's saying square.
Great. And that is why we say that the area is a mathematical concept that measures the amount of space occupied by a flat shape or surface, and the area is calculated by counting the number of unit squares. And what do we mean when we say unit squares? The length of the sides of the square each measure 1 unit. And so this gives us a good coverage of the amount of space. And that is why we say that area is expressed in terms of square units. So, you know, sometimes you'll say centimeter square, millimeter square, meter square. We actually are supposed to say the good math jargon is square millimeters, square centimeters, square meters, because we were measuring our area in terms of square units recognizing that if we were to use unit squares to cover the surface, it gives a way better coverage than any other shape. All right, so that's a fun fact, huh? Isn't that exciting? Are they saying it's exciting, Doc?
Not yet.
Okay. All right, we're gonna talk about units of volume now. All right. What is this whole idea of volume? How would you describe the concept of volume? All right. So the volume now, of course, we're looking to see how many unit cubes we can fit into a particular three-dimensional shape. And we try to get this three-dimensional shape, even though it's on a 2D surface, try to put in all our sides and so on so that we could get that whole three-dimensional feel from it. All right, but we're going to try to fit these cubes. And what's unique about these cubes is that all the dimensions of this cube, of course, measures just 1 unit. All right, and so in order to see how much space can be occupied within this three-dimensional shape, we're going to fill it up with some of these unit cubes. And how will these unit cubes help me to determine the volume of this shape? Anybody would like to answer that? If I'm to fill this shape in black with these unit cubes, several of these, how will that help me to determine the volume of that shape? Any responses?
Not as yet. I know they are thinking. All right, somebody's saying, oh, Xavier's asking you to repeat.
If I'm to fill my black box here with these unit cubes, how can the unit cubes help me to determine the volume of that box? After I fill them up, how will I know the volume of the box?
All right, HD is saying it tells how many cubes can fit into the black blocks.
All right, great. So let's see then. Let's see how many. So let's count. 1, 2, 3, 4, 5, 6. How much is that? 9, 12. So what is the volume of the black box? What is the volume of the black box? What are they saying in the chat?
HD saying 12 unit cubes.
All right, 12 cubic units. All right, thank you so much. So again, remember now, our focus is on the strategies. So we're going to allow you to employ some of these strategies now. So I need you to determine for me. I'm going to give you some questions, and you're going to determine just by identifying whether the question relates to the concept of area or the concept of volume. All right, so let's see. So building a computer lab. The principal wants to build a computer lab on a plot of land next to the school premises. He wants a computer lab to hold as many students as possible. The principal also wants to use the least expensive option for the lab. All right, could you read the other part of the statement for me, Doc?
I am not seeing the screen.
All right. My screen is a little bit cluttered at the moment. All right, so here's a diagram representing the plot of land. There's a section outlined in red. It shows where the principal would like that to be built. All right, thank you.
That you wanted me to read? On the
Sure.
diagram?
Right, above the diagram.
On the diagram below, representing the plot of land, the section outlined in red shows where the principal would like the lab to be built. The section inside the computer lab, shaded gray, shows where the teacher's desk and the chair will be.
Okay, thank you so much. Have we gotten that bit of information? All right, we're moving on. What is the maximum number of two-seater furniture that can fit inside the computer lab? Remember, the space set aside for the teacher's desk and the chair. All right, pay attention to that. Each desk together with 2 chairs occupies a total floor space of 3 square meters. Again, I'm pulling you back into strategies. What strategies could you use to help you to arrive at the solution to this problem? for you to decide whether it's an area problem or a volume problem. What are you thinking? Anything in the chat, Doc?
Not as yet.
Right? So we want to discuss some strategies first, and then we're going to decide whether it's an area problem or a volume problem.
Okay, Davisha says draw. Xavier says a volume.
All right, so you could actually draw a picture, you could make some kind of model, or you could write some number sentences. Those are popular strategies that can be utilized here. So the big question is this an area problem or a volume problem? That's all we want to know for this question.
Okay,
working it
Lashante
out.
says area. Saskia says area, and many others says area.
Would somebody like to type in the chat, why did you say area? What is it about the task that made you decide this is an area problem? We just need one response in the chat. Just one response. Anybody?
Not yet.
Because what are we doing? We're trying to fit chairs into the space, and we know how much space each chair takes up.
All right,
So we're looking-
HD has something here.
Yes.
HD says you are looking at the space covered on the ground.
Thank you so much. Very good. So indeed, this question refers to the concept of area. Very nice. Coming down nicely. Let's look at this one, designing the sandbox. The principal wants to make sure that the students have enough sand to play. Based on her research, she found out the following. The sand in the box should be 25 centimeters deep. The distance between the top of the sandbox and the top of the sand, as shown in the diagram to the left, should be between 5 centimeters and 10 centimeters. Here are your questions. What is the height of the box? Sorry, what is the height of your sandbox in centimeters? What's the height of the sandbox written in meters? And based on your design, fill in the missing measurements on the diagram. But again, what is our focus? We would like to know what strategy would you use to solve this question and whether it's a volume problem or an area problem. What are your thoughts? Someone speaking?
Thank you for calling Concord Trade. My name is Ollie. May I have your name?
All right. Anybody? Anything in the chat, Doc?
Not yet.
We want to know what strategy. Somebody says, Lee says volume. All right.
Okay, yes.
Volume because you have the depths. All right. All right. So Kemoy asking me if it's volume. I want you to tell me, Kemoy.
And Lashante says volume.
All right. All right. So we want to discuss that a little bit. So one of the key things we could do, of course, in terms of strategies for this one is to write a number sentence because we know what it is that we want to find and we know the bits of information that we have. But how much sand will be needed for the sandbox? Again, it is the concept of volume. So one of the things we have to do when we encounter these questions, as we said, before we get into putting pen to paper to write down how we're going to write down our solution, writing down numbers and so on, we need to spend some time to understand the problem. And some problems are written out much longer than others. So you need to read and reread sometimes to get the idea behind the question. So you have to understand the problem. And then again, you go and you brainstorm, identifying where have I seen this problem before and so on. And then you move into which strategy would be most useful based on the information I have to solve this problem. And then you go ahead and utilize your strategy to indeed solve your problem. All right. So we're coming down nice. So we're going to look at a CSEC task exploration, which is our third objective and our third focus for today. And here is our task. Farmer Brown makes troughs. Would you like to read for me, Doc?
Okay. Farmer Brown makes troughs to feed his farm animals using wood that is 5 centimeters thick. As shown in the diagram below, the troughs are rectangular base opened at the top and have external dimensions of 300 centimeters by 190 centimeters by 160 centimeters. Show by calculation that the internal capacity or volume of the trough is 80,000.
Supposed to be
Can't see.
it's 8,091,000. I
Oh,
think the comma is misplaced.
oh, all right, that's a little shady. Okay.
Yes. All right. Sorry about that. All right. So thank you so much, Doc. What are the questions that we want to consider in arriving at an approach to solve this problem? So we need to know, what is the question asking of you? That's critical. So if it is that you didn't understand what you're being asked to do at first, it is no problem to reread the question and reread the question as many times as you need to know for yourself what you are being asked to do. And then once you know what you're being asked to do, then you have to now think, what concepts do I know that I will need in order to solve these questions? And that is why we did the task with you just deciding whether it's an area problem or a volume problem. Because once you make that decision, then of course there's certain calculations and there's certain approaches that you take in working with an area problem that you would not need if you're working with a volume problem. So it's important to understand which concepts can you draw on to help you to solve the problem. And are the concepts related? You know, can I use this to find that? What information do I have that will can be associated with each other in order for me to arrive at a solution? And again, where will we start? What will we do next? All of these. And this means when you see your question, you have to take time, breathe, read the question, understand the question before you begin to attempt to solve it. And then, how will you know when you have solved the problem? That's a critical question, because, you know, sometimes we have a problem and we go through and we think we have an answer, but we didn't read the question thoroughly enough to realize I need to go a step further. I cannot stop here because of what I was asked to do. So that's also very important as we try to determine what strategies we can use to solve the problem. All right. Again, apologize for that typo. But let's go. So now, pardon my environment, what strategies you think we could utilize to solve this problem? Giving you a minute or two, wrapping up in another 15 minutes or so. What strategies do you think we could utilize in solving this problem? Again, the strategies were listed in the chat. You know, we could work backwards in some cases, make a list, see if there's a pattern, do some setting up some kind of equation, some kind of model, all of those strategies. But which of them would be more suitable for this one?
All right, a few persons are saying draw.
All right, so one of the key things that you'd want to do is to make a model, which is, of course, drawing a picture as well, coming up with an equation. Great. Number sentences are important as well. All right, so we're going to start with the top one, drawing a picture. You already have a diagram. What would your picture look like if you wanted to draw a diagram for this? Draw a picture. What picture could you draw that makes this question clearer for you to understand? What would that picture look like? Because you were already provided with a picture. You were already provided with a picture. So what would that picture look like that you would draw? Anybody?
All right, something similar to the picture.
Something similar to the picture that you already have. Okay. Anything else?
Lee says a 3D picture.
A 3D. All right.
The Visha says I would say a square or a cube.
A square or a cube. All right. So let's see. I thought that one of the diagrams that would be most useful, because you have to picture what this thing looks like. And And based on how the diagram is positioned here, you're not able to see a good view of what it looks like for us. So we could start with perhaps an aerial view of what it looks like. Would that be useful for you? You can type yes in the chat. Looking at it from an aerial view perspective. All right, and once we have that, there's some key bits of information that we have to put on our diagram. For example, we realize that the trough is 5 centimeters thick. So we have to take that into consideration. And then we know that it's 190 centimeters on the outside. So I need you to be tuned in with me right now. So it's 1 centimeters on the outside and it's 5 centimeters thick. So what is the dimension of the trough on the inside? What's the length? The same length that we're looking at now. The length that is parallel to that on the inside of the trough. What would be the measurement of that length? Anybody? So we know outer is 190, but because it's 5 centimeters thick, we're only focusing on that little part on the middle that's down the inside of the trough. So what would be that measurement on the inside of the trough?
Davisha is saying 160 centimeters.
160?
Yes.
Want to look at it again?
Okay.
At it again.
Xavier is saying 180 centimeters. 180.
All right, that's more like it because it was 190 and I subtracted 5 centimeters from one end and another 5 centimeters from the other end. So that's a total of 10 centimeters that I would have lost in my entire length. So I'm left only with 180 centimeters. All right, so let's see. And on the other side, likewise, we know it's supposed to be 300 centimeters externally. So what's the dimension internally? What's the dimension internally now? This particular length on the internal side of the trough. That corresponds with an external length of 30 centimeters. Anybody?
Not yet.
I'm sure they're thinking. We talk about patterns, because what was done before is a similar procedure that will apply here. We know that the wall is, yes?
Lee has only 300 centimeters. Xavier says 290.
All right, great. So 290 is it? Because we started with 300 and we had to get rid of 5 centimeters on either end in order to get to the internal dimension. So that's going to be 290. Here's a question for you then. Remember, the height of the trough is 160 centimeters. And remember, the wood or the wood that is used is 5 centimeters thick. So my question to you then would be, sorry, I gave it away. I'm sorry. I wanted to find out what's the height of the trough. Can anybody explain to me how we would find the height of the trough? Or since I gave it to you already, I'll go with it, but explain to me why that is so. Why is that so? Explain the number sentence that I wrote. Internal height of trough, 160 centimeters minus 5 centimeters, which gives me 155 centimeters. Why does that work? Why is that so? Anybody?
Not yet.
Not yet? All right, remember yes?
Maybe we could get somebody to speak.
Sure, who would like to speak? Raise your hand if you would like to verbally respond to this question. Anybody? This is critical, because you're in 4th form, you're heading into 5th form, you're going to be encountering these concepts, which is why we're trying to help you to unearth them at this point. All right, so share with us if you agree or disagree with that number sentence.
All right, so Lee says, well, because the wood is 5 centimeters, so you will take it away from the amount of M/cm up.
The amount of centimeters going upwards, which is the height. All right, because you're going to lose 5 centimeters towards the bottom of the trough because of how thick the wood is. So the actual height of the actual internal height is going to be 5 centimeters less than the external height. Great. I'm hoping that you're following. All right, so let's progress. So again, we have our diagram. How then, because you were asked to calculate the internal capacity or volume in this case of the trough. That's what you were asked to find. We now know the dimensions of the aerial view, which is we can see clearly the dimensions of the internal length and width. And we also know the height internally of the trough. How could I utilize that information now to calculate the volume of the trough? Anybody?
Not yet.
Not yet. I'm sure they're thinking.
Oh, yes, they are.
We're coming down, just about 7 minutes or so to wrap up. We know the length of the internal trough is 290 centimeters. Its width is 180 centimeters. And we know that internally the height of the trough is 155 centimeters. How could I use that information to find the internal volume of the trough? Waiting on those fingers to get typing. Somebody said something, Doc?
Not yet. Okay, somebody's saying 915 centimeters.
Remember, it was actually a proof question, you know, because we were actually asked to prove, because it says show by calculation that the internal capacity of the trough is 8,091,000 cubic centimeters. Of course, again, the comma there is misplaced. So what could we do? So our answer, we know what our answer is. So we're literally working backwards. We know what the answer is, but how do we arrive at that answer is what we're being asked to do. So of course, we have our number sentence again. So the internal volume is going to be, of course, to find our volume, we're going to be calculating, because it's a prism. So we're calculating, we're finding length, we're multiplying our length by our width, by our height. And that is why it was important for us to determine the internal lengths that we're working with, the length and its width, and for us to calculate what the height would have been so that we can calculate our volume. And when we do that, go again, Doc.
Go ahead, continue.
Right, so when we do that, that will allow us to arrive at the internal volume, which would give us a figure that is equal to the one that we were asked to prove. And this is kind of a proof question because we know what our end result should be. So we know now that we have to work backwards in order to work towards that solution. All right?
All right, Angelica have something here, and
Yes.
Halia.
Yes.
Angelica says 180 meters times 290 times 155 equals 8091000. And Halia Hansen says 290 times 180 times 155.
All right, thank you so much. 290 times 180. All right, so that's both of those are equivalent. All right, thank you so much. All right, please try not to mark on the screen for us. All right, great. So here's the final part of our question now. So we already did that. Now we're saying the farmer decides to paint the entire trough. The farmer decides to paint the entire trough. One container of paint will cover 2,000 square centimeters of space. How many tins of paint will be needed to paint the trough? This is a question. You decide on your strategy, and then you're going to go ahead and do your calculations for me. All right, so I need to know how you'd go about this. LJ? All right, how would you go about this? You can open your microphone. We will not have time to go as deep in terms of checking out the strategies and so on. But what problem is this? This part of the question, is it an area problem or a volume problem? Share with me. Open your microphone and share. We just have a few minutes to end our session. Is this part of the question a volume problem or an area problem?
Volume.
Volume? Who said volume? To whom am I
Lee
speaking?
Maria.
Say again?
Lee Maria.
Lee Maria. All right. Why do you say volume though?
Well, miss, because you would need to know the amount of paint that would be in the chart.
And what does the paint cover? The volume? Because you're painting it onto the walls. Are you covering in terms of volume or you're covering in terms of area?
Oh, I didn't realize it would be area.
Yeah. So you see, because you're not filling the space, you're just covering the walls. So this is more of an area problem. All right. Thank you so much for sharing though, Lee Maria. So let's go. So in this case now, we have to be very meticulous. Have you done the concept? What concept in math that you have done that would help you to be able to answer this part of the question relating to area? Because this is not just any small area problem. No, this is a little bit more than the average area problem. But there's a concept that you would have explored in math that would help you to figure out how to find the area of the entire trough. Could you name that concept for me? Anybody? Anybody? Anything in the chat, Doc?
Not yet, Mrs. Sales.
Not yet. There's an abbreviation for it. They always use a 3-letter abbreviation for it, if that's a clue enough. There's always a 3-letter abbreviation for that concept. Something in the chat now, Doc?
Not yet. Yes, pi.
Somebody said
says pi.
pi?
Mm-hmm. Yes.
All right, thank you for that. But conceptually, what we're trying to find is the coverage of the trough. So we want all the faces of the trough, both internally and externally, to be covered in paint. Listen to my words carefully. I want all the faces of the trough, both internally and externally, to be covered in paint. What concept in math is that relating to? And we already established it's an area problem, but what aspect of area does this relate to? I want all the faces of this particular shape to be covered with paint. Anything else? Anything yet?
No, can we give them the first letter of the first word?
T starts with T. 3 letters. T. It's still not helping. All right, so I'm gonna share with you. It's actually finding the total surface area, usually abbreviated TSA. All right, so we're gonna find the total surface area of the trough, both internally and externally. So that's our task. So in terms of finding the outer area of the trough, let's look at these faces. How would I find the area of these 2 faces? Do I know their length? Do I know their height or their width? Do I know that information? Anybody? Those 2 faces. What's the area of each of those faces? Being highlighted by the arrow.
No response as yet.
No response as yet. All right. So because of the time constraint, we're gonna help them out, Dr. White. So yes, the dimension of these faces, we could look to see that the width or the height of these faces is 160 centimeters, and its width or length is 300 centimeters, and we have 2 of them. So that would give us the area of those 2 faces. All right, here's your task. Can you tell me how to find the area of those 2 faces that are in green? Anybody? The green arrow is touching on those faces. Who would like to share with me how we would find the area? And remember now, I'm multiplying by 2 just because I know I have 2 of them. So the area is actually 300 times 160, but because I have two of them, I am doing that in one statement, all right, in one number sentence. What about the second one in green? Anybody would like to give me those dimensions to calculate the area of those faces? Anybody? Anything
Not
done?
yet. Not yet.
The faces in green. All right. So again, it's 190 times
Yes,
160,
Mhm.
and I have two of them. So I did the outer one for you. So now it's your turn to do the inner one. Let's see. The inner faces now, where those black arrows are pointing on the inside of the trough. What would be the area of those two faces? Something in the chat, Doc?
Not as yet. Okay. 2 times 290 times 155.
All right, let's see. Very good. Who said that?
That was Xavier.
Great, Xavier. All right,
And she
internally.
had the other one just before you spoke.
All right, so internally, what's the other one? That's 2 times 180 times 155. Very good. All right, now we're going to look at, so we paint the inside, we paint the outside. What else do we have to paint? Because we don't want the job not to be complete, you know. So where else do we have to paint? Anybody? All right, so we have to paint right along that darkened line there. So we have to paint that too. So what would be the dimensions that we'd need to cover that? What dimensions? How will we find the area of that top part? All right. So we have that and also the other side. So that covers all the space that we want to paint. What do we do with this information? So we found the total surface area both inside and outside. What do we do with that information? Because we want to know how many tins of paint we will need in order to paint this trough. That's what we need. So what do we do? Any suggestions?
Ryan says multiply them.
Multiply them. This represents we know the total outer area, the total inner area, and we know the little aerial view area. How do I determine the number of paint, the number of tins of paint that I will need in order to paint it? The chat is like...
Elia says add them.
And then what?
All right. Okay. Xavier now says add them
all
and
that information.
1,000.
And divide it by?
The 2,000.
2,000. Very good. So that's what we did here. And it says we need 153.7 tins of paint. Is that a good answer? Can I go to the store and say I need 153.7 tins of paint?
Okay. SS says no.
So how many would I request?
They are saying no. Some SS says round it up to 158.
158?
Yes.
All right. So the idea of rounding up is good, but it's not going to be 158.
Okay. Christina says 154.
All
and
right.
Some others are saying 154.
Thank you. So you'd have to buy 154 tins of paint. Thank you so much for participating in today's session. I'm hoping that you found it useful. We meet again in this fashion on June 4, where we're going to spend some more time going through concepts relating to what you would have done in grade 10. And so I am inviting you to join us again on the 4th of June at 5 p.m., where we will go through another of these sessions. Thank you so much for your participation and all the best. Bye-bye, everybody.